So here's a big concept in both Algebra 1 and Algebra 2. It's called the vertex form of a quadratic. And it introduces the letters, and you'll have to forgive me, I'm still congested and been sick for about 2 weeks. My voice isn't what it's supposed to be. But it's got two big letters that really throw kids off in mathematics. You got a group of kids that get it, and again, you got this group of kids who just act like they've never seen it every single day of their life. But it's the H and the K. Now, there's a lot of speculation as to why we chose H and K to do what they do. I don't think anybody has a real answer for it. Maybe you do. Maybe you can comment and tell me why. I think it's just that they were some letters that don't get used often in math, so they were picked. That's my personal opinion. That's not a fact. But the letters H and K show up repetitively, at least here in America, the way we do things. I know some countries use different letters. But when you talk about a line, this might look familiar to you. I rewrote it using H and K. This is what we call point slope formula. And you've probably seen that at least once in your life. But even point slope form can be taught using letters H and K. A circle, that's a big geometry standard, one of the first conics most kids look at. They use H and K. Parabolas that used to be in Tennessee Algebra 2 but are now only in pre-calc. Parabolas where we can find things called the directrix and the focus relatively easy. You'll notice they use the letters H and K. You notice H is always with X, K is always with Y. You have your ellipse. If you don't know what ellipse is, it's basically the eggshell. All right, uses the letters H and K. Hyperbola uses the letters H and K. Hyperbola is basically two parabolas, but that's a hyperbola. And I just assumed you knew what the rest of those things look like. But the letters are big. Like if you plan on being a STEM major or going into a math-oriented field, you have to get the letters H and K down, as it's going to make your life so much easier. Now, let's talk about all these things in vertex form. It's one of the first things we talk about in Algebra 2. I might do absolute value first, but I don't know. A is technically the scale factor. A lot of times we refer to it as the vertical stretch or compression. Now, when I teach Algebra 2, I really try and drill this into kids' heads. It is the initial slope. That means whatever that number is, I'm going to rise or fall that amount within 1 unit, left or right. But it is the initial slope. H, I always call it the horizontal shift. I think a better mathematical word for that would be translation. But it is horizontal. H is for horizontal. And K, the one that kind of doesn't make sense. Why we use it, I'm not sure. Oh, speaking of H, we always do it opposite of the sign. It's negative. It looks negative in here. We'd shift the opposite direction. K is your vertical shift. And again, another word for vertical shift would be translation. That would be the more appropriate mathematical word. Now, let's do a couple of these examples. I've got two straightforward ones and then one that we're going to have to work out and put it in vertex form. There's other ways of doing things. Going after vertex form is not necessarily the best way of doing it. But, you know, we try to create students who can attack things from different directions. And they use whatever works best for them. Not necessarily what teacher did. Because the teacher knows more, right? Teacher can usually see the shortest way to anything. Usually. Not always, usually. So here's the first one up. It's y equals 3 times x minus 1, quantity squared, add 5. And we're just going to identify our pieces here. A is 3. So my initial slope is to rise 3 and run 1. Now, I hadn't even talked about what a parabola looks like. I mean, I approached this as though you knew what a parabola looked like. A parabola, the mother function here, would be y equals x to the second. X to the second, you make a little bitty table.
You take a negative 1 and square it, you get a 1. You take a 0 and square it, you get a 0. You take a 1 and square it, you get a 1. We have these 3 key points. And that is, boys and girls, is what a parabola looks like. So that's what we're going to be redrawing. So this one has an initial slope of 3, and it has to run left and rise 3, and it has to run right and rise 3. Now we talk about the translations that have happened. Remember, this is x minus h, line-up process. H is 1. It's not negative 1, it's positive 1. So we're going to shift right 1. We have the plus k. K is 5, which means we shift up 5. Now, it's also called the vertex form, right? There's lots of ways of teaching this. If you look at it, too, you could also say, oh, okay, I have a vertex at 1, 5, which is a very common way of doing it. There's lots of ways of looking at these things. You don't have to look at everything the same way. So, let's graph this thing. I'm actually kind of a fan of both methods, you know, the shifts and where the vertex is. And I like to draw in the shifts. Students don't really like to, but I like to. So this thing was shifted to the right 1. I like to draw this in because this is a big deal. This is what's called the axis of symmetry. Also, usually when we teach this lesson in Algebra 2, we're talking about things like domain and range and all that good stuff that just goes along with it. There's an up 5. And here's my vertex, which is at 1, 5. Now, this thing had an initial slope of 3. What does that mean? That means that I'm going to have to rise 3 as I run 1. So I put in 3 tick marks. If I run 1 to the left, I'm going to rise 3. Now, this is called the axis of symmetry. If I'm 1 unit to the left, I'm also going to be 1 unit to the right of it at the same place, because parabolas have symmetry. And there's my little parabola. Now, it's worth talking about this because maybe what you're doing is requiring you to talk about the same thing. So it's worth talking about the domain and the range, all right? Our domain. This graph will run forever left and it will run forever right. Its domain can be written one of 2 ways. I prefer interval notation. The lowest x value would be negative infinity. The highest x value would be positive infinity. Now you might also see that written as, that's a really horrible curly brace. Remember, I'm not that good at curly braces. All values of x such that x is an element of the real. Now sometimes we dumb that down. I've seen this on state tests. They'll just say, curly braces, all values of x such that x is any real number. And that's one way they write it down in state test, just to kind of dumb it down a little bit. Range, which is your values of y. The lowest y value is 5, and this thing rises to infinity as it moves left or right, and the highest y value is 5. Every once in a while you run across kids who like what we call set builder notation. So it would be all values of y such that y is greater than or equal to 5. And that's how it would be written. Nobody would put an or statement on that one and try and make it. They might say y is any number greater than or equal to 5 in words, but we're just going to use symbolism. So there's your first example, and it was not a bad example. It wasn't. All right, moving on to our next one. It'd be kind of cool if this was somehow electronic and I could just clear the page, wouldn't it? Just leave that mother function up there. You're supposed to, I think most textbooks and most other teachers call them parent functions, but I like to say mother function because I might just screw the word up one time. I don't think I've ever done it. If I have, it's been a long time. It's been so long I don't remember doing it. All right, the next one, let's use a little bit different notation. Let's call it f of x, something that messes with kids' heads if we introduce the f. I don't know why it messes with your heads. It just does. It's the same thing. f of x is just a fancy way of saying y. That's all it is. All right, so let's talk about some things here. On this one, if we line up with vertex form, we'll find that our vertex, or h and k, remember your vertex is the letters h and k, is at -3, -4. Remember I wrote earlier that you change the sign on that one? And that gets a lot of kids. Kids just want it to be what it is. And I tell them this all the time. When you leave a set of parentheses in algebra, you'll almost always change the signs. If you're talking about having a function, that's kind of the golden rule that you fall back onto. Now, a is technically 2. Technically it is. We'll just go with -2, okay? And this is your initial slope. We are going to fall 2 units as we run 1 unit left and right. Now, why are we doing that as we run left and right? It's because we're doing a parabola. Now, this one has, because a is negative, we have what's called a vertical reflection. And that's worth talking about. It is, and it should be talked about. It stinks for some kids that they just can't seem to make it stick, but then instead of opening up, it has been vertically reflected and it opens down. Okay? Now, I talked about that being a vertical stretch or compression. This would be a stretch. It is growing downward twice as fast as normal. But anyways, I don't want to put too much into this. This is just about basic graphing. So we have a vertex at -3, -4. There's your vertex. And again, I like to go ahead and draw in the shifts too. This is a big one. This is called the axis of symmetry. That's what this is, the axis of symmetry. And it's at x equals -3. That's what's going to be, the parabola will be symmetrical about. The horizontal, or the vertical shift is never anything really to deal with the axis of symmetry. Now we have an initial slope of -2, which means that I'm going to have to fall 2 units as I run 1 to the right. And I'm going to have to fall 2 units as I run 1 to the left, because I expected this thing to be upside down because it started with a negative symbol. Parabolas do have some curvature to them. And there she is. And again, let's go ahead and talk about the domain, and let's talk about the range. The domain of this one, and the domain for any parabola in vertex form, and that particular vertex form, is always going to be from -infinity to infinity, because it runs left forever and it runs right forever. The range, the lowest y value is actually -infinity. And it rises on both sides of the parabola up to this y value of -4. Bracket on -4. Maybe you remember, maybe you don't. If you like what we call set boulder notation, all values of x such that x is an element of the real. Or, this one's kind of different, all values of y, I almost wrote an x there out of habit, such that y is less than or equal to -4. And I think that's about everything I want to talk about on that one. Now the last one is kind of a harder skill for a lot of kids. I've seen this on several standardized tests. They will give you an equation that's not in vertex form. And there's lots of ways of finding vertexes. There's formulas you can do. I was taught, and I still teach to this day, I don't push it like I should, how to convert a standard equation straight into vertex form. And the quickest way of doing it is something I did a lesson on yesterday. It's called completing the square. So here's one that's given in standard form. This is y equals x squared minus 8x plus 10. And what we're going to do is we're going to put it in vertex form by completing the square. All right. Now, here's how we're going to do that. Steps for completing the square involve finding half of the b term. We're going to find b over 2 squared, and we're going to add to both sides. Add it to both sides. That's how we normally do it. But anyways, we have x squared minus 8x, and b over 2 would be negative 8 over 2, which is negative 4. If you square a negative 4, you get 16. All right. Now I'm going to put that right next to the 8x. I already had a 10 over there, okay? That didn't go anywhere. And if I add it to the left, or the right-hand side, sorry, I was in deep thought, I was somewhere else. If I add it to the right, I have to add it to the left for purposes of equality. Usually I just do these things in my head. It's kind of weird to write them out. It kind of threw me off for a second. If I focus on this, I have created a little piece here that factors as x minus 4 times x minus 4. And in yesterday's video, I talked about how we can make what's called perfect squares. And I still have this plus 10. X minus 4 written twice is an x minus 4 that's squared. And by the way, on the left-hand side, I still have y plus 16. Now, it's really, really close to being in vertex form. Vertex form has the y isolated by itself. So all we have to do is we have to take the 16 away from 10. And 10 minus 16 is negative 6. And then we get something that looks like a times x minus h quantity squared plus k. Now, in mathematics, you have to understand what I call the understood and what most people call the understood. And it's a surprise, if you're a teacher watching this video, and you probably understand this, it is an alarming number of kids who do not understand the understood one. But a is 1. This thing is going to rise 1 and run 1 from both sides of the vertex. But a is 1. That's again your initial slope. Your vertex is at positive 4, negative 6. Or you can think about that as shifting right 4 and down 6, however you want to think about it. And we have everything we need. I saw this on some TCAP practice as which equation reveals the vertex. They gave a standard equation, and then they gave equations in vertex form. You had to figure out which one was right. And there's at least 2 ways of doing that. If it was on the calculator, there's a whole bunch of other ways of doing that. But lots of ways of figuring these out. Vertex is at 4, negative 6. It'd be about right there. And again, I love to draw this in. Kids do not. Kids like to do the least amount of work as possible. That's just the way students are. Even the really good ones, they don't want to do it either. And I guess I was probably the same way as a kid, you know, just trying to get done, get out of here. We have an initial slope of 1, so whether we're going left or right, we get to rise 1 unit, and that's it. And the only problem with vertex form is vertex form does not tell you where you cross the x-axis. So it's not a very good graph in essence, but it's a quick graph. That's what it is. And I don't know where this thing crosses the x-axis unless I do a little bit more math, right? I didn't give you something that factored, so it'd be the quadratic formula. But that's a pretty close approximation. Now, your domain for this one is still negative infinity to infinity. Your range for this one has a low y value of negative 6. Some kids catch on real quick to that. Has a high y value of infinity. This guy right here, so important. Your axis of symmetry. Is at x equals 4. And you'll notice I tried to draw everything with symmetry about that line there. I tried to make the left look like the right. There you go, kids. That is the vertex form of a parabola.